Using bar models. Solve this problem in small groups. Pause the video, share some of your solutions, then restart the video. Pause the video to discuss some of these reflection questions, then restart the video. The concrete, pictorial, abstract model is a cyclical approach to learning math. Students keep returning to the concrete and pictorial as the math concepts become more complex. It is crucial that teachers make the connections between the concrete, the pictorial, and the abstract explicit to students. The bar model is used to understand and represent problems. Students first learn the model with part-part whole and comparison, addition, and subtraction problems. Then they use it for equal parts with multiplication and division problems, and then fractions. The bar model is also used for two-part problems that include equal parts and part-part whole or comparison problems. Bar models provide a bridge for students between concrete objects and abstract symbolic representations. They are an ideal representation to support students in understanding key ideas in the junior, intermediate, and senior math curriculum. For example, for ratio, proportion, and the idea of a variable. Bar models can help students in understanding key mathematical structures. For representations to become useful for students, they need to be offered consistently over time and in different contexts. This graphic shows how the bar model is used in MyMathPath and can be used in secondary math classes. You can see that it is used for many concepts and is gradually faded out as the students progress through the grades. The importance of the bar model cannot be overemphasized. Bar models are used consistently from MyMathPath grade 3 onward and become a bedrock for proportional reasoning and algebraic thinking in later grades. They work as well for part-part whole relationships and comparisons in MyMathPath 3 as they do for fraction operations and proportions in later grades. The teacher's guide in MyMathPath explains the importance of the bar model and gives suggestions for how to use them during the lesson. For example, in the grade 3 teacher guide, lesson 2 of chapter 4 suggests having paper strips prepared for the teaching and guided learning parts of the lesson. Paper strips are used again in chapter 11 when the bar model is used to represent multiplication and division. It is crucial to use manipulatives before the pictorial representation is displayed on the smartboard when the bar model is being introduced in grade 3, and again when it is used for more complex concepts like proportional reasoning and algebraic thinking. The chapter overview is very helpful for understanding how the bar model will be used in the lessons. It also shows the progression of use through the neighboring grades. This is from the grade 4 teacher guide. The chart on the right shows how the bar model was used in grade 3 and how it will be used in grade 5. Bar model diagrams use rectangles to represent both known and unknown quantities and the relationship between them in mathematical problems. The build-up to using the bar model representation begins in the primary grades, with students placing discrete objects in a line to model a problem before using individual bars with an object in each box. The use of discrete objects can be replaced by the introduction of bars. Strips of paper can be used to represent the rectangles, allowing for some physical manipulation. Students would then move to drawing bars. The problems above demonstrate both addition and subtraction as part-part whole relationships. On the left, you can see bar models can be used to represent problems involving any sort of additive comparison. For example, what's the difference between 48 and 16? Or, if you have 16, how many more to make 48? These diagrams support the idea of subtraction as difference and as the inverse of addition. On the right, there's a multiplicative comparison problem. Problems involving situations where two or more quantities are connected by a multiplicative relationship or ratio can be succinctly modeled. For example, if we know that there are 3 times as many girls as boys in a class, and there are 32 students altogether, the bar model above can be drawn. The bottom model clearly shows that the ratio of boys to girls is 1 to 3. But the students may find the whole easier to visualize on that top model. They will need time and practice to see that the bracket also represents the whole, and it is important for them to see bar models used in both ways. Where problems involve the sum of equal quantities or quantities being divided into equal parts, a bar model can be used to show these relationships. These problems are examples from grade 3 where the bar model is introduced. Pause the video and take a minute to read the problems. These pages are from the grade 4 student textbook, Recall Prior Knowledge for Chapter 4. These are all the different versions of the bar model that students would have learned in grade 3. Pause the video to take a look at them. Once the students have mastered the 6 types of bar model representations from grade 3, they move on to using them for multi-step problems in grade 4. The problems often have equal parts and comparison situations. The grade 4 teacher's resource suggests beginning with paper strips. Cuisenaire rods can also be used once the students have proficiency with the paper. In the problem on the left, you can see that the same model is used to solve both parts of the problem and is scaffolded for the students using the letters A and B to match the problem with the model. It would be helpful to have paper strips and paper price tags that can be manipulated by the students. Once they have the paper models with the numbers, they can then write the equations to match the letters A and B in the textbook. On the right, the problem of the lesson is a multiplicative comparison. I used Cuisenaire rods to model it, so that it is clear that the 1 brown rod represents Jenny's 8 books, and the 4 brown rods represent Jenny's sister's books. Once students have represented the problem with the rods, they can then draw the rectangles to match and write the equations. How did you solve this problem at the beginning of our session? Maybe you solved this problem algebraically. Or maybe this just looks like a bunch of gibberish. It certainly would to students. Can you imagine a grade 5 or 6 student solving this problem? They could with the bar model representation of the problem. Let's take a look. Let's try to represent this problem using bar models. Where can we start? Think about the first phrase in the problem. I have 6 times as many muffins as scones. Well, we can start by drawing a bar model that represents that relationship. For every 1 scone, there are 6 muffins. there are twice as many muffins as donuts, which means there are half as many donuts as muffins. So now we can add some bars to represent the donuts. I have 170 pastries altogether. That can be represented by a bracket showing that all of those groups together are 170 pastries. The number of pastries is represented by 10 bars altogether. 6 plus 1 plus 3. So now we can take 170 pastries and divide it by 10 to find out the value of 1 bar. So 170 divided by 10 is 17 pastries per group or bar. So there are 17 scones, and there are 3 times 17 donuts, which is 51. We could also find out how many muffins there were by multiplying 6 times 17. You can find more resources by going to the Educators Playground, K-6 Numeracy, clicking on Visual Representations, and then scrolling down to where you can see the section on bar models. There's the progression of the bar model, and then if you look at that bar model video icon and click on it, you will find a curated list of 25 different videos on representing problems with bar models. There is also a link to a bar models guidance document, which goes into detail about different ways of using bar models to solve problems. Thank you. If you have any questions or would like any support with using the bar model in your class, please contact your instructional coach.